All right, geometry. Here's some problems involving arc lengths and whatnot. So it says in circle K, the measure of arc JL is 82 degrees. Find the measure of angle JLK. So they're telling us that this JL, this arc right here, is 82 degrees. Again, remember, arc measure is in degrees. They want to know what the measure of angle JKL is. What is this angle here? Well, this is a central angle. And we have to remember that the central angle is equal to its minor arc. So if the arc is 82 degrees, so is this central angle. Now, vice versa, if I gave you the angle measure was 82, you would also know that this arc measure is also 82 degrees. Submit that. Oh, yeah. Okay, that was our first problem there. Easy peasy. All right, let's take a look at our first arc length question. So it says in circle S, with measure of angle RST being 126 degrees, is what it should say, degrees, and RS equaling 3 units, find the length of arc RT round to the nearest hundredth. So this angle is 126 degrees, right? Which also means that this arc's measure is 126 degrees, not its length, its measure. RS is 3. 3 is your radius. So your radius is 3. And they want you to find the length of RT. So find this length here. I'll call that L. Okay. So as I told you, I'm going to break this into two parts. Now, the arc length formula is this. The length of the arc is the angle out of 360 times the circumference. You can plug it all in at once, okay? But just to try to alleviate some people's confusion, let's first find the circumference. So circumference is equal to 2 pi r, and your radius is 3. So the circumference is 6 pi. Now, we're not going to multiply it out. We're not, okay? But just to tell you what 6 pi is, it's again, let's estimate, right? Pi is 3.14, so 6 times 3 is about 18. That's the circumference, okay? So now, number 2, we're going to take the 6 pi, plug it in for the circumference, and we're going to multiply it by the angle measure out of 360. So to find my length, I'm going to take the angle measure, which is 126. I'm going to divide by 360 and times it by 6 pi. Now, I'm going to enter this in my calculator in just a minute, but let's just talk for a second, right? How much of the circle does this section look like? I would say it looks about 1/3, right? So what would be 1/3 of 18? Well, 1/3 of 18 is roughly equal to 6. So what I'm trying to get at is when you do these calculations, you should have an idea of what the answer is going to be. I should expect my answer to be around 6. Now, if it's not exactly 6, don't freak out. But I'm thinking like, 5.9, 7.2, somewhere around 6, okay? So let me show you how to input this right here into Desmos graphing calculator, okay? And we'll round to the nearest hundredth, so we'll talk about that when we get there, okay? All right, so 120, I'm going to take a picture because I'll forget. 126 over 366 pi. All right, so let's go to the graphing calculator. So we'll do 126 divided by 360, arrow to the right, times, and it was, I believe, 6 pi. And you could find the pi button down here on the keyboard, or if you press pi, there's pi. And look what I got. As I mentioned, roughly around 6. Now, this is actually a tricky rounding, so pay attention. We need to round to the nearest hundredth, which is the 9. This 7 is going to round the 9 up to a 10, which is actually going to make the 5 here become a 6. This answer is 6.60. That is tricky, right? Because if you round 0.59 up, it becomes 0.60. So be careful with this rounding. I hate if you get the problem wrong just because you can't round right. 6.60. So I come back here, as we thought, 6.60. There we go, and we are correct. Awesome. All right, next problem's coming. All right, so let's take a look at this problem here. So this problem says, circle O, shown below, has a radius of 10 inches. Find to the nearest tenth of a degree the measure of the angle x that forms an arc whose length is 13 inches. So this is kind of a strange question, and the reason is they give you the radius. The radius is 10. And they give you the arc length. The arc length is 13. It's right there. they do not give you the angle measure. You're looking for the angle measure. So again, remember this formula, arc length equals the angle measure out of 360 times the circumference. Well, because they don't give us all of the right side, we're going to have to actually solve this problem here in a second. Okay. So let's talk about how we're going to do that. Let's plug in what we know. So we know 13 here. We don't know our angle measure, call it x. 360 is 360. And the circumference that's 2 pi r. So that's 2 pi times 10. So here's what's going to happen. This stuff right here is going to go up into the top, and my x is going to come after. All right, so like the following. 13 equals, so I'm going to multiply 2 times 10 to get 20. 20 pi over 360, and then the x comes after. And now, to get the x by itself, when you're multiplying by a fraction, you can get the fraction gone by multiplying by the reciprocal. Let me do it in a different color. So if I multiply by 360 over 2 over 20 pi on both sides, 360 over 20 pi. What's going to happen is the 20 pi's will cancel, the 360 will cancel, and there's x all by itself. And now you need to multiply this out. Now, I would suggest using Desmos graphing calculator. If you don't, you need to make sure you put the 20 pi in parentheses. Because if you do 20 and then press the pi button in your calculator, it's going to divide by 20 and then multiply by pi, which is not right. Okay, so just trust me. If you're not using Desmos graphing calculator, put that in a fraction or in a parenthesis. Now, before we type this in, look at this picture here. What do you think? What do you think this angle measure is going to be? Doesn't this almost look like a 90-degree angle? So I bet you x is just going to be a little bit less than 90 degrees. Now, if it's not 90, don't freak out. Something like 72, 78, 84, something like that. So have an idea going into the problem. But nonetheless, all we have to do is type in that multiplication problem that I have circled. So let's go do that right now. So here we're going to do 360 divided by 20 pi times 13. And look, 74.48. I believe it says round to the nearest tenth. So when you round that to the nearest tenth, 74.48, the 8 makes the 4 become a 5, 74.5 degrees. And there's your angle measure, something a little bit less than 90 degrees. So again, I'm a big proponent in having an idea going into the solution to see if I'm right. 74.5. Oh, yeah. All right, let's do one more type of problem here together. All right, so now it's a circle O shown below has an arc length of 19 inches subtended by an angle of 51 degrees. That just means the central angle is 51 degrees. Don't worry about this word subtended, okay? Find the length of the radius x to the nearest tenth of an inch. Okay, so now we have to find the radius, right? This is our r. They do give us the arc length. They give us the angle measure. This symbol is theta. It's Greek. It just means angle. So now, again, my formula is arc length equals angle out of 360 times the circumference. Sorry. So again, I'm going to fill in what I know. So I know that the arc length is 19. I know my angle measure is 51 out of 360. And my circumference, remember, circumference is 2 pi r. I know 2 pi, but I don't know my radius, so call that x. So what I'm going to do is this 2 pi is just going to multiply to the top. So 19 equals, so we're going to do 2 times 51, that's 102. The pi comes along out of 360, and then the x is after. And again, this idea of when I'm multiplying by a fraction, to undo that, let's just multiply by the reciprocal. Times by 360 over 102 pi, times by 360 over 102 pi. And again, put the 102 pi in parentheses. And again, for the radius, this is kind of hard to see, right? I mean, if you try to straighten out this 19, To me, this 19 and this X look about the same length. Now, I don't know if I can visualize it like that, but if I try to straighten out 19, I'm going to assume it's going to be something similar to that. So we'll see. So again, this is what needs to go in the calculator because the right side all cancels, and there's your radius X. So let's do that together. Take a picture. All right, here we go. So let's see if my prediction is right. So 360, not 360, 360 divided by 102 pi times, press arrow over, times 19. And there we go, 21.34, round to the nearest tenth. So that 4 does not change the 3. 21.3, and that'd be inches. And we were kind of right, right? The radius and the arc length looked about the same if you were able to flatten out the arc length. Okay, so let's go back to Delta Math. 21.3. And there we go. Okay. So again, some different variations on some arc length problems. Do your best. There is one more video. It's going to be an edge elastic covering some word problems. So make sure you tune into that one. All right. Thanks for watching.